12-2, Angles and Angle Measure. Objective, draw and find angles in standard position. Convert between degree measures and radian measures. Let's talk about what a standard position for an angle is. The standard position is an initial side, and the initial side has to be the positive part of the x-axis. And the terminal side is where the other side of the angle lands, and that's going to be the terminal side where it ends. Now, angles always turn. A positive angle will always go counterclockwise right here. Now, in this case, this is an example of a positive angle. Here is the initial, always here on the positive x-axis, and here's the terminal, and counterclockwise, this represents 120 degrees. Remember that this will be 0 degrees, this will be 90 degrees, this will be 180 degrees. So it makes sense that the terminal is going to be between 90 and 180. Over here, this is a negative angle. This is 0 degrees. This is negative 90, because when you're turning clockwise, it's going to be a negative angle, negative 180 degrees. Negative 145 is between negative 90 and negative 180. So that looks like a good position here. Let's go ahead and practice. We're going to draw an angle with a measure of 210 degrees in the standard position. Okay, we're going to start with the initial. This is the initial part of the angle, and we're going to turn counterclockwise past 180 and between 180 and 270, and that's what we're going to draw. And this is our angle. It's a very big angle, 210 degrees. Okay, let's go ahead and draw another one. This time it's a negative angle. So again, we're going to start at the initial, but we're not going to move counterclockwise. We're going to move clockwise, and we're going to go halfway right here, and that's going to be negative 45 degrees, because negative 45 is between 0 and negative 90. Okay, your turn. See if you can pick the correct answer. And here's the correct answer. One more time. And here's the correct answer. Let's go talk about drawing an angle with a 900 degree rotation. All right, and so 900 degrees means we're going to be going around a couple of times. 900 degrees is made up of 360 plus 360 plus 180. So this is the initial part of our angle right here, and we're going to turn all the way around. That's 360, and then all the way around, another 360, and then we're going to turn 180, and we're going to end up here. And so our terminal side is going to look like this. And this is actually a straight angle. That's what we learned in geometry. All right, your turn. Pause. And here's the answer. Okay, let's talk about this new word called coterminal. Well, terminal means where it ends. Co means other angles that have the same stopping point. Okay, so let's take a look at this 60-degree angle right here. This is 60 degrees, but there are other angles that have this same stopping point. And one of them is to go 60 degrees and then all the way around. So if we go up to 60 degrees and then all the way around one time, we're going to end up here. And what we say that 420 will get us to the same place, same coterminal place. So we're going to end up here. Now we can also do it going in the negative direction. So right here, we're going to start at our initial, and then we're going to go all the way around, but this will be setting us negative angle, and we're going to end up in the same place where 60 degrees is, and we call this a coterminal angle. So all of these end up at the same place. So you can either add a whole revolution, or you can subtract a revolution to get your negative angle. Okay, let's go ahead and practice that. I'm looking at 210 degrees, which is this angle right here. So in order to figure out another coterminal angle, I'm going to take 210, add another revolution, and so this answer will be 570 degrees. So I can go all the way here, all the way around again, and I'll be in the same position. Now to get the negative angle, that's this blue one right here, we're going to take 360 and we're going to subtract the 210. And then we're going to get 150 degrees. And this will be a, I needed to do it the other way around. 210 take away 360, otherwise we won't get a negative angle. And so this will be negative 150 degrees. So to get to the same position, I can get there by going negative 150 degrees. Okay, let's go ahead and do it again. This time I have a negative angle, and so to get the other negative angle, I just take 120 and I go another revolution, which means go in the same negative direction. And so I'm going to get negative 480 degrees. Now to get the positive part, I'm going to take 360 and then I am going to subtract 120 and my answer will be 240 degrees. So it'll take 240 degrees going in this direction to meet up right here. Okay, pause, see if you can do, and here's the answer. All right, let's talk about converting between degrees and radians. Radian is a measure of higher level mathematics. We don't measure in degrees, we measure in radians. And a radian comes from the word radius. So what's happening is we want to figure out how many radii it takes to open up this angle. How many radii? How many of this if I were to take this and roll it across here? Well, one thing we have to remember is a circumference is 2 pi r. So this is telling us we have 2 pi radians that go all the way around a circle, 2 pi radians here. So if you go all the way around a circle, 2 pi radians, that's the same thing as 360 degrees. If you go halfway around the circle, that's the same as 180 degrees. So pi radians is the same thing as 180 degrees, or 180 degrees is the same as pi radians. Let's get a little better feel for what this angle looks like. So this is 0 radians, and then this is going to be pi. So halfway around is pi. Now this is pi thirds, so I'm going to divide it into thirds. And this is going to be pi thirds. So this angle goes, here's the initial, and here's the terminal right here. I should have wrote thirds, not halves. Okay, now since I know that pi is 180 degrees, I can convert it by saying 180 divided by 3, and so this is actually a 60-degree angle. So 60 degrees is the same thing as pi thirds. Okay, let's find the angle 2 pi thirds. Okay, so this is 0 radians, this is pi. This is 2 pi thirds, so let's divide it into thirds again. And here's my terminal, my initial. And I'm going to go 1/3, 2/3. So I'm going to go right here. So this is 2 pi thirds. All right, so 2 pi thirds. A quick way to change it is to remember that pi represents 180. And then we're going to divide it by 3. 3 goes into here once, 3 goes into here 60 times. And so this answer is 120 degrees. So 120 degrees is the same thing as 2 pi thirds. Okay, let's talk about pi halves. Now here's 0 and here's pi. So pi halves is just halfway right here, halfway. Here's the initial, here's the terminal, and this is pi halves. And I hope you can see that pi halves is the same as 90 degrees. Okay, pi fourths. Now this is 0 radians, this is pi, and if you divide it into fourths, right here, this initial and terminal, that's going to make pi fourths. Pi fourths is 1/4 of the way around here. So pi fourths, same thing as taking 180 dividing by 4, or this represents 45 degrees, or half of 90. So just so that you get a better feel for radians. All right, let's go ahead and rewrite 30 degrees in radians. Now 30 degrees is 1/3 of this way, because it takes 6 of these 30-degree angles to get over here to 180 degrees. Okay, so one way you could do it is you can use radians over pi equals degrees over 180. Just use a proportion. And so we're looking for radians, so I'm going to keep that as r, and the degrees is 30. And when I reduce that, that's going to be 1/6. And when I cross multiply, this is going to be pi 6. Pi 6 is the radian measure for 30 degrees. Let's go ahead and convert -5 pi thirds. Now -5 pi thirds, there's a shortcut and then there's the way that I just showed you. But I want you to get a better feel for -5 pi thirds. -5 pi thirds is -3 pi thirds. Take away 2 pi thirds because -3 and -2 make the -5. Well, -3 pi thirds is really halfway around, and then you got to go -2 thirds. So this is an angle. It's a pretty big angle. It's a negative angle, but it's pretty big. Okay, so to convert it, the shortcut is to remember that pi is another way of saying 180. And then I go ahead and reduce, and then this answer is -300 degrees, which that looks like a big angle, 300 degrees. Now, if you don't want to use the shortcut, you can use our formula that I just showed you. Just put the radian measure here, and we're going to cross multiply. So this is -5 pi thirds times 180 is equal to pi d. Do a little bit of reducing, 60. So that's -300 pi equals pi d. And if you divide both sides by pi, your degrees is equal to -300 degrees. So use whatever method you like. Okay, let's pause. And here's the answer. Pause. And here's the answer. Now here's a little summary of all our angles that we know in degrees and what their conversion is in radians. Our last concept is a central angle and then arc length. Okay, a central angle is made up of 2 radii. That's why it's called central, because it's using the center. Let's go ahead and see how to find this arc length right here. How to figure out this length. How do you figure that out? Well, when you were in geometry last year and you were working in degrees, arc length was the measure over 360 times 2 pi r. That's the way you had to do it last year. Well, now that you know a whole revolution is 2 pi, instead of writing 360, we're going to write 2 pi, and then I'll write 2 pi r. The 2's are going to reduce, the pi's are going to reduce. So this ends up being the angle measure, which we call theta, times the radius. So it's a much nicer formula with radians than what you learned last year with degrees. Okay, let's go ahead and do a problem. We want to find the arc length, and here's our formula. S is equal to r theta. The radius is 16. The angle is 3 pi halves. Put it over 1, do a little reducing, and the answer is 24 pi. And this is in feet because this is a length. S is equal to r theta. R is 13. Our angle is pi 6. So this is going to be 13 pi over 6. You can't reduce. And it says to do it to the nearest tenth, which means we need to put it in the calculator, and I'll assume that you can do that. Okay, your turn. And here are the answers.